Alright, in the last video, I covered how the wave function collapse works logically, and now we are going to start to implement the actual coding. So the first thing we need to do is actually create rule sets for what can exist next to each other. So I'm manually placing these, but we know next to this specific tile, I just call this top left, it can only have this tile, and this tile. So we need to actually create some type of a structure to save that information, and then in the future we will pull from that to select what will randomly get chosen. So the way we're going to do this is we're going to start working in our project. First thing we need to do is just create a wave function collapse folder. I have a subfolder called tutorial because I still have all of my own wave function collapse stuff implemented, and I'd prefer not to have to make a whole entire new project, as there's a lot that goes into this. Perfect. Next thing, right click, blueprint class, actor. This can be named whatever you'd like. You can just name it WFC actor, WFC calculation, whatever. Within here, we are going to be performing all of the calculations and rendering of our wave function collapse. I decided against, we won't be using multi-threading natively. In this tutorial, I will try to keep it as accessible as possible so anyone can use it. And then in the future, I will demonstrate how to add multi-threading to improve the efficiency of the entire algorithm, as well as cover some C++ implementations that will help while keeping it pretty native to blueprints. All right, so the next thing we need to do is we need to create an enumerator. That's done right-clicking, blueprint enumeration. If you don't know what an enumerator is, it is just a data type that allows us to have multiple options so we can select from one of these. And that's done by just adding a numerator and then naming it the corresponding things that we need. For this specific enumerator, I've named it tiles, and I have named from 0 to 8 of the different tiles that I will be using. I would recommend that you use them as well, and I will link the store page. It's a free tile set, and I might actually link my own because I added in a blank tile, because this has 8 tiles but not a blank tile. I had to add that in manually just to allow for an empty space when we're generating it on an actual tile map. Perfect. So name those, describe them, what they literally are. It's blank, it's filled, it's the top left, top middle, top right, right dot, filled, left dot. It's as simple as I can do it. I'm not going to do a more complicated tile set yet, because that will add a little more layer of complexity, so we're going to keep it simple for now. And so if you're watching this trying to implement it in 3D, a lot of what I do can be taken into 3D quite easily. Well, not really easily. It adds another layer of complexity too, but you would have to do something similar where you would have each of your 3D tiles, name them, and then follow kind of what I'm about to do next. And that is creating a structure. I have a tile rules struct, and that's done by right-clicking, blueprint, structure. Now, within most coding languages, there's what's referred to as structs, and inside of structs, you can have different data types, and you can save lots of information. A common struct would be something like a profile. Within your profile struct, you would have a name, first name, last name, address, phone number, and each of those would be different types of data variables or data types. And so we're going to use a blueprint structure, which is made by actually having to create an entire blueprint structure. And then we're going to add 4 variables. They're going to be set to the type tiles set to this enumerator, and then made into a set. And essentially what a set is going to do is allow so there can only be unique elements within each of these variables. And as you see, I've named it top, bottom, left, and right. That is because this will contain each neighbor's possibilities. So if we look over here again, we'll just say this tile right here. The top of it can only exist, the only tiles that can be selected, as we can see, nothing matches, so it can only be the blank tile. The left of it can have several things. It can have that, it can have that. I guess that's it. So it can have two things. And so on. The bottom is this. It is also this. To the right is this, as well as this, as well as this. And then I already did top, which was just the blank. So, and that's what this is. We're going to be adding in those actual tiles into these sets. So for now, you just need to create top, bottom, left, right, have them set to the variable type tiles in a set. Perfect. The next thing we're going to do is hop into our blueprint graph. Not sure why this is here. We'll just, oh, that's why. Sorry, ignore that. All right. On event begin play, we're going to create a new function. So you can add a function here and just name it initialize and then drag and drop it in place and connect it over. So whenever the actor is called into play, which I did forget to mention, you should drop your actor within your environment. This is going to be where it will generate in the future. So when it is called into play, it will then run this initialize function. Within the initialize function, I have a collapsed graph referred to as define tile rules. If we hop in here, we can see, oh, look, it tells us it loops. We can see what's going on here. Perfect. So I have a for loop and it is running for the number of entries in tiles -1. So it's getting the max number of these. There are 9 of them. It starts at 0, ends at 8. That means there's 9. And we're subtracting 1 to 0 it out. So it'll go from 0 to 8, just like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 8. And then from there, we are going to create the rules. So we need to add a variable. It needs to be set to the structure we just made. So that's tile rules struct. And then if you right click it, it'll turn it to an array, or you can come over to the right side and set it to an array. And then just drop that into the environment and connect it to an add node. And then from there, pull off, type in select. This select will allow us to, it just cleans up code. If you've never used select nodes, it makes things a lot simpler. You'll have to add the number of pins that exist. So there being 8. There are a few ways to do this. You could use switches. I just prefer the select in this case because it doesn't slow down. Selects can cause inefficiencies if you're doing calculations in every single option, because every time you would call on this select, it would have to compute every option. But because these are going to purely be data, it's incredibly fast. It's negligible. I did calculations and actually looked at the difference between using a switch and a select, and it's completely negligible. All right, perfect. So if that makes sense, we've connected the index of the looped body to the index of the select, having 0 to 8 options. And then from there, we need to pull off. I'm going to pull this to the side, and we're going to make tile rule struct. And this is where we're going to actually create the different neighbors that can exist. All I've done is I have collapsed nodes right there to keep things a lot cleaner. Because if we hop in, we can see in my own, we have a few more things. So going back again, we pulled make tile rules struct. It's got top, bottom, left, and right. It's currently connected to 0. So I'm just going to reopen up over here. This is ground 0. And we can see I have come in and manually made the rules for what can exist next to one another. This is kind of tedious. There technically could be more dynamic algorithmic ways to do this, but it starts to get complicated. And so for now, we're just going to have to do this by hand. I would recommend either visualizing it or writing it down, what needs to exist next to each other. So for instance, I remember I've opened up the blank tile, and from there I pull off, okay, it's top neighbor, what can exist next to a blank tile, what can exist above a blank tile. Only one thing can in this tile set, and that is another blank tile. And bottom, what can exist under it? Well, you can have another blank tile, you can have the top left, top middle, top right. We see that? It's because they have this connection to the blank. So any of these can exist under a blank, and an empty airspace can exist under itself. And yeah, so I mean, gosh, it is kind of tedious. There are going to be 4 neighbor directions for each, and depending on the size of your tile set, it can start to get pretty big pretty quick. And this is one of the biggest causes of errors. If you don't get this right, things will start to break because it will get into impossible scenarios where it needed something you missed, and because it's not there, we won't be able to select it. But I'll just quickly go over. So we see top, blank, bottom. I'm just going to kind of hover over them quick because there's a lot. So this is for the filled. You can just kind of look at it. I can't really do this too nice. I might type it out. It's kind of a lot of work, so we'll see. For now, I will just give you a quick overlook. Make sure to pause. I might have already done this one. Top right. Left. Right. Left dot. And right dot. Perfect. So the best I can give you for now is to just go in and pause and then manually put those in. I will consider typing them out. That sounds like a lot of work, so we will see about that. And yeah, that's about it. You can collapse all of this into another node like I did to keep things clean. And that will be it for this video. In the next video, we're going to go over what I refer to as the entropy array. That is another bit of the algorithm that needs to be initialized at the beginning of play. So if you have any questions, feel free to ask. As I said in the latest devlog, I did make a Discord, so feel free to hop in and ask me questions.